Alright guys, so today we're going to go back actually in the textbook. I know we've already covered 5.2, 5.3, and 5.6, but we're going to go back to 5.1, and you're finally going to learn how to solve all these problems by using calculus rather than geometry or estimations using the Riemann sums. Okay? So what I'm going to do today is, I'm only going to introduce you to very basic rules of antidifferentiation. Remember, the first time you were learning how to differentiate, at first we started slowly, right? I first taught you the power rule. Remember, that was the very first rule that I taught you, right? Then I taught you like the derivative of sine, cosine, etc. Eventually we went to the product, the quotient, the chain rule, inverses, etc. So it's going to have the same progression, but now we're going to do antidifferentiation. Okay? So we are going to start with how to undo the chain rule today. I mean, not the chain rule, I'm sorry, the power rule. The power rule. And how to find the antiderivative of all those simple trig functions, etc. Okay? So first of all, let's start out with an example. So let's pretend that I tell you that f of x equals to x squared plus 7, and I ask you to find the derivative of that. Okay? What's the derivative?
F prime of x is equal to 2x.
Thank you, very good. Okay? Now, I give you another function. F of x equals to x squared plus 6. What's f prime of x?
F prime of, are we going to learn like plus b right now?
Please ignore that, student. Continuing. F of x equals to x squared minus 5. What's the derivative?
2x.
Okay. We are able to take different types of functions, find the derivative, and realize that the derivative of all of them are exactly the same. Now, when we antidifferentiate, we have to go backwards. So pretend I never even gave you this. Pretend I gave you this and I ask you to go backwards. How is it that the same thing can give you so many different answers? And how are you going to be able to achieve finding a specific answer? You're not going to be able to, unless I provide you with information. There's no way that you could have guessed that this going back from here to here was going to be a 7. Or going back from here to here was going to be a 6, etc. Okay? There's no way to do that. What you do know for sure is that you're going to have a constant. Do you guys agree that these are all just different constants? So when we do this process, it's going to be very important that you write down plus c. And I'll explain to you what that means here in just a second. Okay? Now, we're going to start out with the very first rule of undoing this derivative. Okay? To go from here to here, you did 2 times the number in front, right? And then you subtract it by 1. Agreed? So 2 times 1, you got the 2. 2 minus 1 is the 1 power. The constant went away, the derivative of constant is 0. Agreed? Well, antidifferentiation is literally the opposite of this. So just like when you multiply to undo it, you divide, or when you divide to undo, you multiply. We're going to do everything backwards, opposite. Okay, bless you. First, on this one, you took the 2 when you multiply, right? Then you subtract it by 1. Well, do that process but backwards. Here, you're going to add 1 and divide by whatever number that is. So let's pretend that you have the integral of x of n dx. Cool? This is your first rule. Instead of subtracting, you're going to do what? Add 1. So this becomes x n plus 1. And what are you going to do with that number that you found?
Divided by n. Oh, yeah.
Divide the entire thing by n plus 1. Now, how do you know that there wasn't a constant there? You don't know. And that's the reason why you put plus c. Okay? Try it. Like here, if you were to do that, you were to add 1, so that's 2, right? 2 divided by 2 is 1. We're back to x squared. Agreed? Now, you don't know that there was a constant. That's the reason why I put the plus c. You with me? Questions about how to undo the power rule? So this is your first rule of integration. That's another word for antidifferentiation. So now what we're going to do is we're going to practice a few problems. Okay? So here's your very first example. we want to integrate 3x dx. Okay? Thoughts? Yes, sir.
What do they, so first you have to add 1 to the power,
So that becomes,
squared, and then divide by 2.
yes,
Plus
plus c. Agreed? Now, if it reduces, reduce it. If it doesn't, then just leave it. How can you check to make sure that this is the correct answer?
differentiate.
Differentiate is the derivative of this 3x. Yes, it is. So, do not forget your plus c. For those of you watching this video, if you are watching this video and you are taking the AP exam, if you forget to put the plus c, the entire thing is wrong.
No.
Okay? If you're in my class and you're watching this video, starting now, quiz this test. If you don't put the plus c, even if it's right, I'm going to count it wrong to get you used to it. I do not want them to penalize you in the AP exam just because I gave you leniency throughout the year and you just kept forgetting. Okay? Alright, next example. The integral from of 1 over x to the third dx. So far you only know one rule, so you got to find a way to apply it. 1 over x to the third power dx. You're going to rewrite it as what? X to the negative third power dx.
So it'd be x to the negative second divided by negative 2. So negative 2 over x
What else are we forgetting?
plus c.
Plus c. Now, you cannot leave the answer like that. They're going to ask you to clean it up. What does this look like?
Negative 2 over x squared plus c.
No.
Oh.
Negative 1 over
My bad.
2x squared plus c. Be careful. Slow down. Right? Okay, now I'm going to give you a few to try. So if you're watching the video, try the next ones. Pause the video. When you're ready, come back and check the answer. So here you go, guys. Square root of x dx. The integral of x plus 2 dx. The integral of 3x to the fourth power minus 5x squared plus x dx. And lastly, the integral of x plus 1 over the square root of x dx. Now, keep in mind, I've only shown you one rule, so you got to figure out a way to use that rule. Okay? So go ahead and pause the video, and when you're ready, hit play, and I will show you the answers. Alright, so for the very first one, the first thing you got to do is rewrite it such that you have the integral of x to the 1/2 power dx, and apply the rule. Add 1 to 1/2, and you get 1 divided by 3/2 is 2/3 plus c. Yes? Yeah, that's fine. Leave it like that, it's okay. Yep. Now, here, you can just take it term by term. So if you add 1 to the power of this one, you're going to get x squared, and then you got to divide, right? So 1/2 plus 2x plus c. Check your work. 2 times 1/2 is 1. Goes on the power, you get the x. 2x, the derivative of 2x will be 2. We're good, right? The derivative of a constant will be gone by then. Yes? Okay, next one. X to the 5th. 3 divided by 5. Minus x to 5x to the 3rd over 3. Plus x squared over plus c. Now this one was the more challenging one. You had to use your algebra skills a little bit. So first thing I would do is I would rewrite this as x over root x plus 1 over root x dx. Now what's x over root x? Square root of x, because you subtract powers, right? This is to the power of 1, and that's to the power of 1/2. 1 minus 1/2 is 1/2, so x to the 1/2 is square root of x, yes? And 1 over square root of x is x to the negative 1/2, right? I don't even know why I wrote this as a root. This should just be a 1/2, right? Just get rid of that. We're good. Dx. So if we integrate this, if we add 1 to 1/2, you get 3/2, right? X to the 3/2, and divide by that, it would be 2/3. What happens if you add 1 to negative 1/2? Positive 1/2. So it would be a 2 plus C. Questions on any of those four? We're good? Okay, so now I'm about to show you about 6, 7 rules.
Great.
But these are rules that you already know and they're common sense. Okay? Alright, if you are watching this video, let me go ahead and reflect it. Because I don't feel like writing all these rules. So if you're watching the video, go ahead and pause it and copy down these rules. For those of you in class, let me give you a digital version here in just a second. So I'm going to pause the video. Alright, now that you know how to integrate trig functions, there's your next 3 problems. Try them. So you have 2 sine x dx, integral of 3 over x dx, and the integral of sine x over cosine square x dx. Okay? Alright. Let's go over this. The very first one, go ahead and take out the 2 outside of the integral, so you have the integral of sine x dx. What is the integral of sine x dx? Negative cosine times 2. Negative 2 cosine x plus c. Do not forget your constant of integration. Okay? Next one. Take out the 3. So this becomes 3 integral of 1 over x dx. You should recognize this. What has a derivative of 1 over x? Ln x. Therefore, 3 natural log of x plus c. Okay? Last one. Again, you don't know any type of quotient rule or anything like that. You only know how to undo either the power rule or one of those trig functions that you have memorized. Well, this one doesn't look like any of the ones we have memorized. However, you can play around with it. You can write it as sine of x over cosine x dx. What would happen if I do that? Sine over cosine is tangent. 1 over cosine is secant. So it becomes the integral of tangent x secant x dx. What has a derivative that is tangent secant? Secant x plus c. This take practice. So if you ask me, like, how did you know to do that? You're just going to have to play around with your identities from trigonometry. So I suggest that if you don't remember your identities from trigonometry, you go back and study your Pythagorean identities. Sine square x plus cosine square x equals to 1. Tangent square x plus 1 equals to secant square x. Cotangent square x plus 1 equals to cosecant square x plus 1. And all the other basic ones, tangent is sine over cosine, cotangent is cosine over sine, etc., etc. Okay? Alright. How are we doing so far? We're good? Okay, stay with me. We're almost done. The last thing I'm going to show you today is what happens if I actually do want you to find out what that C value is, what that constant is. Well, in order for you to find out what that constant is, I'm going to have to give you some information in order for you to solve it. Okay? So what we're going to start off with is we're going to solve what we call a differential equation. Okay? So let's say that I give you a differential equation. dy over dx is equal to 3x squared minus 1. This is known as a differential equation.
So we have to integrate it to find y.
Now, do you understand why this is called a differential equation?
Yeah, because
It's an equation, and this is a derivative, right? Differential equation. You with me? Now, let's say that I ask you, like, to take the integral of this thing, to actually find out the
x cubed plus c.
y equals per se, right?
X
Now,
cubed minus x.
hold on. what you're going to have to do is separate the variables. On the left-hand side, you're dealing with y and x. You want y to be on one side and you want x's to be on the other side. How can you get rid of this dx? Yes? And hopefully this will explain to you why integrals have the dx with it. Okay? Now, I am going to integrate both sides because it's an equation. And what I do to one side, I have to do to the other. Agreed? So if I do, I want to integrate. Now, notice that the left-hand side is being integrated with respect to y, while the right-hand side is being integrated with respect to x. Cool? What is the integral of dy? What else? Plus c.
Wait, what? Oh, right.
There's technically a 1 right here, right? What's the derivative of y?
1.
1 dy. There you go. Right? Apply the same thing on the right-hand side. Wouldn't this be x to the third minus x? We're integrating plus c. Yes? You guys with me? What do you notice will happen? But can you though? How do you know that they're the same?
So one's differentiated to y and one's differentiated to x.
So nothing guarantees that these two constants are the same. Like this could be a 7 and this could be a 1. This could be a 100, that could be a 0. So do not cancel out the constants. What you do want to do is combine them. It's technically, if you subtract them together, you're still going to get a constant, right?
Yeah.
That constant could still be 0. Agreed? So what you want to do is you wanted this to be y equals, right? So all you got to do is say y equals x cubed minus x plus c. When you combine those constants, you just get another constant. You still don't know what it is, right? You're with me? Yes, sir.
If it's minus c, it can now be minus c or plus c?
Plus or minus, it doesn't matter. Because once you figure out what c is, it could be positive or negative, and then you just put it in positive or negative. Do you see what I'm saying?
Yeah.
Okay. Now, what you just did is you figured out, you didn't complete solve a differential equation. Okay? You figure out the equation, and this equation has multiple solutions. Okay? Because of this plus c. Now, I'm first going to show you what this looks like graphically. If you were to graph this, are you going to get one particular graph?
No.
No, because this c is going to change. For example, it could be 0, it could be 1, 2, 3, 4, 1/2, 0.1. It could be anything as long as it's a constant. So, what you're going to have to do is you're going to create something that is called a slope field. Slope field. Slope fields take a while to create. So please pay attention. First of all, let's pretend that c is 0. Okay? So if c is 0, we plug in, we're going to graph this. So if we plug in 0 for x, that's 0 cubed minus 0, so that'll be 0, right? Agreed? Now what if you plug in 1? 1 to the third power is minus 1. 1 for x, but we're still pretending this is 0. You know what I'm saying? So we're plugging in 1. So that's 1 cubed minus 1 is? What if I plug in negative 1? Also 0, right? You guys with me so far? Negative 1 cubed is negative 1 minus negative 1 is 0, right? Okay, I'm still pretending that c is 0. Okay? Now I'm going to plug in 2. 2 to the third power minus 2. So I don't know, 2, 6, somewhere up here. Cool? I'm going to plug in negative 2. Negative 6, right? Now, that's just, if I go any further than that, I'm not going to be able to fit on my page, right? Now, you see my knowledge from algebra. I know that these zeros only occur once. I'm going to have to cross, right? So this thing should look something like this. And I'm not going to use a solid line. I'm going to use a dotted line. That's how the graph would look if C was equal to 0. Okay? And I'm going to put that next to my graph so that I don't forget. We're going to repeat that entire process, but now I'm going to let C equal to negative 1.
You just move it down.
You just move down each point 1, because you know your transformations from algebra, right? Each point gets moved down 1. So let's say this one comes down here, this one comes down here, down, 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 and then this thing looks like
Same thing.
that's if C equals to negative 1, right? What would happen if C is negative 2?
Move it down another one. What? This is it?
What if C equals to 1?
You move it up. What is the point of this?
Stay with me. And you can do this forever and ever and ever until you get a page full of a whole bunch of slopes. Now I'm tired of doing it, but this thing, like I can cover this entire page and it's just going to look like a whole bunch of lines. But when you look at this, do you think it's pretty obvious what the shape of this graph looks like just by looking at it? You know that it's some kind of S, right? Agreed? Now, you may be given a slope field, and we're not going to use them that much right now. I'm just introducing you to what they look like. We're going to further talk about slope fields later on in the year. But let's pretend that I gave you, instead of this, I gave you the slope field, right? And I told you that I am interested on you finding the actual equation of the line that goes through this point right here. This one right here, which is 0, negative 1. And I wanted you to actually find the equation. So here's what you just figured out. You technically know that f of x is equal to x to the third power minus x plus c. Agreed? That was what you discovered. And by me giving you this information, I technically told you that f of 0 equals to negative 1. Do you have enough information to figure out what c is? You sure do. F of 0 equals to 0 to the third power minus 0 plus c, and that's got to be equal to negative 1, right? You with me? Therefore, c equals to negative 1. Therefore, f of x equals to x to the third power minus x minus 1. And that would be your equation, including the constant, a very specific constant. A constant that makes you go through this point. Same equation. What if I told you that it has the point 1, negative 2? What are you going to have to do? You know that f of x is equal to what? X to the third minus x plus c. And what do you know from this point right here? F of 1 equals to negative 2. Yes? So repeat the process. F of 1 is equal to 1 to the third power minus 1 plus c, and that's got to be equal to negative 2. Yes? 1 to the third power is 1 minus 1 plus c equals to negative 2. Therefore, c is equal to negative 2. And therefore, f of x equals to x to the third power minus x minus 2. And that's how you can find out exactly what the constant of integration is equal to, if and only if you are given a point. Then you can find out exactly what that number is. If you are not given a point, you must include plus c. Understood? And that brings our lesson to an end for today. Yes, sir.
Let's say you wanted to figure out the y plus c and the x plus c constant. How do you do that?
You will need information about two separate graphs, y plus c, and then x cubed minus x plus c. You don't, there's no reason for us to want to do that anyways. So, it's just adding more work. And remember, calculus is not about let's make it more difficult. It's let's find an efficient way to find a solution. So it will be very inefficient for, is that a word? Inefficient?
Yeah.
Yeah, inefficient for us to try to do both sides here. Okay? Alright, any questions on 5.1, anti-differentiation, differential equations, and slope fields? We're good? Alright, so that's all I got for you. Homework is on the calendar. Thank you for watching.
You're welcome.